Yes, so hello everyone. So in this video we are going to learn about the logic gates. So just to begin with, let's start with what are logic gates. What are logic gates? So logic gates are like switches that turn on or off depending on what the user is doing. So logic gates turn on when certain condition is true and off when the condition is false. They are the building blocks of digital circuits and generally how computers work. So logic gates are used to process and manipulate binary data, and signals within digital circuits. So binary data, these are the zeros and the ones. Marks the binary data, where zero is also just the logic low and one is the logic high. So we'll do basic logic gates in this video, and there are three fundamental logic gates, which are namely the NOT gate, the OR gate, and the AND gate. And from these three, other complex logic gates can be derived, which these logic gates are the NOR gate, the NAND gate, the exclusive OR gate, and the exclusive NOR gate. We'll start with the NOT gate. This is the most simple logic gate, and it has only one input and one output. So it's basically very simple. And NOT gate takes in an input whether it is an on or off, and just gives the exact opposite of it. It inverts the input signal. So if you input a 1, which is a logic high, it will give you a 0, which is a logic low. So if the input is 0, it will give an output as 1. So it is also referred to as an inverter because it inverts the output. So here is this is the symbol of the NOT gate, and we have this is the input and this is the output. Only one input, one output. So the truth table, A is the inputs and Q is the output. So if you have as input as 0, the output will be a 1. And if the input is 1, which is a logic high, it will give you an off signal or a logic low signal, which is just read as an inverse. So we move to the next, which is the OR gate. So unlike the input, the NOT gate, it has 2 inputs and 1 output. The OR gate needs at least one input to be on for the output to be on. So if both inputs are off, the output will be off. So that's the condition. So as you can see in these pictures down here, in picture 1 here, we have one input is a logic high and the other is a logic low, and it gives a logic high output. If both are logic low, the input also is a logic low. We don't have an output, it becomes off. And if both are logic high, we have a logic high output, it becomes on. So this is the symbol of a 2 input OR gate, where we have 2 inputs and input A and B and 1 output. So this is the truth table. So it is only off when both inputs are off, as you can see here. Both inputs are off and we have a off, and the rest are on when at least one signal is on. Moving on, we have the AND gate, which is the final one which you are going to tackle, and just as the OR gate, it has 2 inputs and 1 output, and it only turns on when the inputs are on, when both inputs are on. So we should mark the word both. So both inputs should be logic high or on for the gear to be on. So if only one input is on or both inputs are off, then the output is off. As you can see in picture 1 here, the inputs, both inputs are logic high, so we have a logic high output, and in these two, one is logic high and the other is logic low, so the output will be off, it will be logic low. So this is the symbol here, and if you can note the difference between the symbol of a AND gate and then OR gate. And here we have the truth table, where if both inputs are off, the output is off. If one input A is off, input B is on, still be off. Input A is on, input B is off, still be off. And if both inputs are on, this is the only condition which fulfills the condition. So that's it for the basic logic gates, and thanks for watching.